Kentucky has a need for quality, affordable housing that can withstand severe weather. And Somerset Community College is hard at work on a unique solution, 3D printed concrete houses. Our Mackenzie Spink has more on how the Floodbuster project will keep Kentucky families safe.
Somerset is now home to the state's first 3D printed house. The concrete structure still needs interior walls and a roof, but it represents a big step in solving some of Kentucky's greatest housing challenges. This project started when the U.S. Department of Agriculture and the Appalachian Regional Commission provided Somerset Community College with a grant to create 3D printed, weather-resilient housing as a response to the 2022 flooding in eastern Kentucky.
You know, they'll still get wet, they'll still be flooded, but you can go and clean them back out, and then you can move right in without having the mold or respiratory issues that often come with a flooded house.
Part of the home's sturdiness comes from the material, concrete instead of wood frame. But the true resilience of the design is hidden inside the walls.
The Floodbuster itself is a design that is built into the curves. It's a weave of concrete in a specific shape. We use finite element analysis and high-end engineering software to create like the ultimate solution to the forces coming against it. And the residents, you know, they'll just be sitting in a comfortable, safe home. All the while it could take the hit, you know, potentially of a Class 4 flood or the winds of an F4 tornado. It's the corners and the connections that usually will fail. And so knowing that that's why the house collapses, we designed the Floodbuster to be in those zones. And so all we did was take the same floor plan and add in the Floodbuster design.
3D printing with concrete does have its challenges. High temperatures or even a small breeze can affect how the concrete dries. But engineers say this process is faster and less costly than traditional house construction. Using 3D printing, a house could be completed in just 40 hours.
It's almost impossible to make with conventional approach. You just can't form concrete that way. We've had concrete for 2,000 years. This is the first time we've ever had the ability to uniquely shape it without any cost increase.
Wooldridge says building a house this way takes less work in the construction phase and instead requires more attention in the design and planning process on the front end.
The goal here is to allow the ultimate engineering approach to be used in construction, meaning that we have everything planned out, we have all the pieces figured out, the printer is placing it right where we want to, and a house comes together, you know, like a Toyota Camry up in Georgetown. That's the goal. You know, efficiency, because we now have an automated approach to construct something that will last 100, 150 years.
Work on Floodbuster 2 is already underway. This first home served as a proof of concept and testing ground for the innovative technology. But Floodbuster 2 will go through more traditional construction processes and will eventually be occupied. For Kentucky Edition, I'm Mackenzie Spink.
One of the partners of the Floodbuster project is Habitat for Humanity, which has already expressed interest in using this technology in its mission to provide housing to low-income or disadvantaged groups.